Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework for worksheet 8.4. Remember that if you have a problem with one particular problem on your worksheet, fast forward to that number and this problem will mirror it and we should be able to help you out. Let's get started. All right, our first problem asks us to reflect the triangle DML over the y-axis and then translate it 2 units left. So first of all, to do the translation, first we're going to mark our x-axis, and then we take any point and we go perpendicular to it. So notice down here I went over, and in this case I went over 3. So I'm going to go over on the other side 3 as well. Okay? And that is where this point, this is where M prime is going to end up, so to speak. And now we do the same with each of the points. So notice here, this goes over that 1, 2, 3, 5. And so the next one goes over 5. And that's our point. And you can see that our triangle is going to flip over and become right there. Notice, of course, the L came all the way over here, farther, 1, 2, 3, 4, 5, 6, and 6 over there. The triangle flips, so the farthest point is still the farthest point from the line. The next part then is to translate 2 units left. So notice I take that and go over 2. Every point goes over 2. So my whole triangle just slides over 2. And there's my final product. Problem number 2, we're going to translate DML down 1 and then reflect it over the x-axis. All right. So first step, let's go down 1. I'm going to take that whole line down 1. And I'm going to take the D down 1. So notice my whole triangle just slides down 1. Now to find the x-axis, we mark it here. And notice we draw a perpendicular line to it and then go the same distance over the other side. Here we go down 1, so 1 the other side. So this line LM, you see, is going to end up right here. The whole thing, both points. Whereas up top, it's down 1, 2, 3, 4 lines there. So we go 4 lines the other side. So my D's going to end up down there, and now my new triangle ends up right there. And that's our composite transformation. All right, problem 3 asks us to reflect the triangle over the line x equal 1 and then translate it 1 unit left and 4 units up. So let's start with the translation. First, the line x equal 1. Notice it's a vertical line on the where x equals 1 on the number line here. Think of it going up and down. All along here, x equals 1. This is the x equal 1 line. All right. So the reflection, we take any point and go to the x equal 1 line, like there, and notice we went over 2, so we go over 2 on the other side. That will be the reflection. So point D goes over to that point there. And the same, notice M is right on the line, so it's going to stay right there. It doesn't go anyplace because it's actually on the line of reflection. Whereas L goes over 3, and so it's going to go over 3 on the other side as well. And so our whole triangle ends up reflecting in that fashion. Now the next part says to translate it 1 left and 4 up. So take a point, go over 1 and up 4. Next one, go over 1, up 4. And then the last point, over 1, up 4. And there's where our new triangle is. And that's the problem. Problem 4 asks us to translate the triangle 3 units right and 3 units up, and then reflect it over the y equal minus 2 line. So let's do the translation first. Pick a point, go over 3 and up 3, and there's our point. And notice I could do that for all the lines, but I can see my whole triangle is just going to translate up 3 and over 3. Now where's the y equal 2 line? Well, along the y-axis, here's where y equals minus 2. Y equals minus 2 is a horizontal line. So I'm going to put a horizontal line there, and that's what I'm going to translate over. So now we go down perpendicular to that line and across. So if I take the first point, down 1 over 1, so that's where the new point's going to be. And then for the other 2 points, they're down 2 and over 2. And you see my triangle flips over there, and there's my resulting final transformation. Problem 5 simply presents this to us. Triangle ABC is translated down 4 and then reflected over the x-axis. So if I have a triangle, just give you a perspective here. If I have a triangle sitting someplace here, it's going to go down 4 So it's something like this. And then it goes over the x-axis, which is here, and so it gets reflected, something like that. And the question is, can you assume that this triangle and this triangle are congruent? And the answer is yes, because both a translation and a reflection are rigid motions. Rigid motion means that the distance, the length of the sides, and the angles don't change. So as a result, you know that those two triangles are going to be the same. They will remain congruent. Rigid motions preserve distance and angle measure. Problem 6 notes that any quadrilateral, if you rotate it 180 degrees counterclockwise to produce an image, is there a way of doing it other than a rotation? And the answer is there's two ways to do it. And one way is to reflect it across the x and then across the y. Let me show you algebraically how that works. The rule for 180 degrees is that xy becomes minus x minus y. All right. So let's talk about what a reflection across the x. You would notice that xy, the x stays the same, but the y switches. Okay. And this is across the x-axis. Now, if I reflect across the y-axis, when I do that, the x stays the same, the y stays the same, but the x changes. So come down here, and I've got this. And notice if I flip it now, reflected across the y, the x stays the same and the y is there. So notice those actually act the same. And we could do the same here. 180 degrees means that xy becomes minus x minus y. If I reflect first over the y-axis, then my xy becomes, across the y-axis, it's the x that changed and the y stays the same. But then when I reflect across the x-axis, at this point putting this in here, reflect this across the x-axis, the x stays the same, minus x, and the y changes. So once again, we end up with the same thing. So two reflections, reflecting over the x and over the y, is the same as rotating it 180 degrees. Problem 7 asks us to describe in detail the transformations or transformations from the preimage ABC to the image DEF, the triangle. First thing I usually notice on problems like these is I ask the question, the first thing I try to do is to get the triangles oriented the same way. This is easiest to do with patty paper. Draw your patty paper and say, do I have to rotate or reflect anything to get there? And if I look here, I notice that if I put a patty paper, I could go directly there without rotating it or reflecting it. And that's important because it means all I have to do in this problem is a translation. So I notice that what I need to do is go down 6 and left 3 for each of them, and that's where I get. So the transformation then is going to be xy simply goes to x minus 3 and y minus 6. And that's a simple transformation. In our last one, we're doing the same thing as 7. This time, however, my first notice about using patty paper is helpful because to get these triangles rotated, I notice that to get these the same way, I can't rotate them around, but I can reflect them. So if I reflect this across that line, notice across the line, I end up with the two triangles being in the same orientation. Now all I have to do is translate it down 6. Notice I come down 6 to each point, and there's my translation. If I were putting this together as a rule, my first reflection here was that xy, because it's a reflection, the y stayed the same. That became minus x, y. Now if I'm going to go down 6, it's going to be minus x and then y minus 6. So my ultimate, I could write this as xy becomes minus x and then y minus 6 would be the rule for that composite conformation. All right, hope that helps you. Have a good night.